have our 3 kind of sequential steps, what I'm going to do is make a summary sketch. I'm going to draw my replication fork very simply. Not going to write in base pair lines. I'm going to draw in my helicase, labeling it with the letter H and showing that it's continuing to move down. I'm going to label my ends 3', 5', 5', 3'. I want you to imagine that we have put DNA polymerase here on the leading strand and it has moved from 3' to 5', adding bases. So I will put in, I'll just draw in our second sugar phosphate backbone. And I'll say this is our leading strand. Because DNA polymerase can just move straight on through from the 3' end to the 5' end. As you know, that is not the case for the uppermost strand here, because we can only move 3' to 5' in the areas that helicase has already unzipped. So instead of getting one continuous strand, we get little pieces. But all of these pieces are in the 3' to 5' orientation. Because our DNA polymerase has moved from 3' to 5'. It just had to do so starting from over here. So our DNA polymerase started here, moved down, created a fragment, detached, came here because this helicase at that time was unzipped to here. Then it did that fragment. When it ran into a fragment that it already did, it detaches, comes back, helicase is now here, reattaches, moves 3' to 5' again to do the next fragment. These pieces, or these fragments of DNA, have a special name. And these little pieces are called Okazaki Fragments, named after the person who discovered them. And here we are going to add one more note, and that is that after DNA polymerase completes Okazaki fragments on the lagging strand, the pieces of new DNA are connected using an enzyme called DNA ligase. I'm going to highlight that DNA ligase in green and show you that it is going to come in here and connect the Okazaki fragments together.